Hello, ladies and gentlemen. This video is just a short video. I just want to remind you, if you have forgotten, how you can evaluate some different trig expressions. And so as you see up here in front of me, we have sine of pi over 3. I know this is something you do in trigonometry. This is something, though, that we're going to need to be able to do well here as we move forward in calculus. And I thought if you need help with this, here's just a video to help you with it. So to get started, I need to think of what is sine of pi over 3. In particular, I need to understand maybe what is pi. So one thing that I've used in the past is knowing this fact that in a unit circle or on a circle, pi itself is actually half of a period, which means it's halfway around my circle. And so in my mind, this is what I'm always thinking of. Pi is the equivalent of 180 degrees. So since a full revolution is 2 pi, that's 360 degrees, pi itself is like having 180. So when they ask this question of what's sine of pi over 3, it's kind of like saying in terms of degrees, 180 over 3, or the same thing as sine of 60 degrees. So this question's asking me what the sine of 60 is. Now why it changes into degrees is because if I create a triangle to evaluate, again, this trig ratio of sine, I know that 60 degrees is going to lie in the first quadrant. And if I go 60 degrees from the start, I actually can create from that 60 degrees a right triangle, and in particular, a special right triangle. And the special right triangle is a 30, 60, 90 triangle. When I draw my triangles, I always go back to the x-axis like that. This would be my 30. Now, some of us remember, some of us maybe don't. It's been a while, but the rules for a 30, 60, 90 triangle are this. The short leg is the one across from the 30. That one is, I call it x, and everything is based upon that. So the hypotenuse is double that, it's 2x. And then the long leg across from the 60 is x times the square root of 3. So this picture here is kind of like my model now that I'm going to use as I come back over here. So when it asks me over here, what is the sine of 60, I need to remember that sine, go back to SOHCAHTOA, sine is opposite over hypotenuse. And so kind of the question now is, what is opposite? What's my hypotenuse? And I just have to refer back to my triangle here. In my triangle, from my angle of 60, opposite is my x squared of 3. The hypotenuse is my 2x. And so when it says what is sine of 60, I'm actually going to have x squared root of 3, that's my opposite, over the hypotenuse 2x. And this is the way I leave it. I leave it with the x's in there because what always happens is you're going to have an x in the top and the bottom, and my x's are going to cancel out. And so my final answer is going to be the square root of 3 over 2. And so what is the sine of pi over 3? The exact answer is the square root of 3 over 2. Your calculator, if it's in radians, you can type in the sine of pi over 3, and it's going to tell you some decimal. This should be the exact equivalent of that same decimal, but that's an exact form. I like these problems because, again, they take a little thinking and take some thought into what you've used before. Next, though, one last one. So same question. So if you, again, want to see another one, a different format, here's cosine of pi over 4. Very similar. Again, using the logic that pi is 180, this is kind of like having cosine of 180 over 4. And cosine of 180 over 4 is then the same thing as 45, cosine of 45, because 180 divided by 4 should be 45. So then at the same time, what I'm asking myself is if I created a 45-degree angle, what this actually creates is a 45, 45, 90 triangle, which again is one of my special right triangle rules. And the rules for a 45, 45, 90 look like this, where if each leg is the same, since it's isosceles, I call those x, The hypotenuse is x times the radical of 2. So I go back over, and if I remember, cosine is again adjacent over hypotenuse. So in my mind, as I think of that's what that turns out to be, cosine in our case, from my 45-degree angles perspective, the adjacent is the x. The hypotenuse obviously is the x squared of 2. So in our problem, we're going to end up with x over x square root of 2. And what cancels out are the x's. So really I'm left with 1 over the radical of 2, square root of 2. And again, we know this for a fact that we were always taught this is improper to have a radical in the denominator. A radical is irrational. You cannot divide by an irrational number. Only later on when we're doing limits in calculus can you. But if I'm evaluating, I can't do that. So to fix this, I rationalize this by multiplying by the square root of 2 on top and bottom. It's a well-chosen one. So I end up with the square root of 2 over 2 for an answer. So, again, going back, what's the cosine of pi over 4? The exact answer is the square root of 2 over 2. Hopefully this helps. Maybe that's a little refresher how to evaluate, but I like to change my pi into a degree, so 180. I'll figure out then where in my unit circle that falls, and from there create a triangle, and from that triangle then create a ratio, and that ratio then should be my answer. Hopefully this helps, and I will let you get to work.